Today's lesson is going to be about heat energy. We're going to go through this process skill worksheet from the Primary 4, but the Primary 5 can also use this video for your learning. Simply pause the video when the questions are shown, try it on paper before you carry on and play the explanation and to show the answer. In this worksheet, we're going to look through how to read diagrams, graphs, experimental setups, and how to apply this knowledge of heat energy in novel situations. Let's get started. I'm Mr. Long, and I will be your science teacher today. Now, let's take a look at this question. There are 4 containers that are made of different materials, as shown below. They are placed in a basin of hot water. In one of my previous videos, I talked about words have meaning, and you got to pick up the words in a question that suggests to you what is this topic about. Nobody will tell you in the test that this is about heat energy. You got to make that conclusion and inference yourself. So when you see 4 containers, it tells you, oh, more than one, I must make some comparison. Also, I see hot water. That tells me that is a heat source. And these are clues to tell me that this question must be about the heat conductivity of materials. And that is a concept being tested in this question. When we talk about heat conductivity of materials, we talk about there could be materials that are good conductor of heat, and there could be materials that are poor conductor of heat. Let's see what the question wants us to actually tell them. When we look at the diagram, alright, we see these 4 different materials. Ice cream is immersed, is placed into each of these 4 different materials, 4 different containers, my apologies. And these 4 containers are dipped into some hot water. The water did not actually get into the container, alright, they're actually outside the container. And here, when I see hot water, I know this is a heat source. Heat source means that it will start losing heat to the surroundings. I'm making an assumption here that the surrounding is most likely to be at room temperature. Hot water should be definitely above maybe 40, 50 degrees Celsius, maybe as high as 90, even 100 degrees Celsius. Right, and this hot water will be losing heat to the surrounding gradually. What does it mean? It means that it's like the container it's like losing heat to the surrounding, and the surroundings into the air, the table that this is resting on, as well as the container. The container is also gaining heat from the hot water. Alright, so the hot water is losing heat to the container. And once the container gains heat, it is now getting hotter and hotter, and you will start to melt the ice cream that's inside the container. So the question asks us, which stick of ice cream will take the longest time to melt? Longest time to melt. That means that the container must slow down heat transfer the most. So let's take a look again. The concept that was supposed to be tested here is about heat conductivity of materials. So they're looking for poor conductors of heat here, definitely. So by just looking at these 4 materials, I can see that these 3 are all metals. And based on what I have learned in my classroom, I know that metals are better conductor of heat. They are non-metals, usually. So if I ask you, it's a question asks us which is the poorest conductor of heat. It's very clear, the plastic material is the poorest conductor of heat. Alright? Now, and since the ice cream are at a lower temperature than the surroundings, such as the hot water, and then of course the container that is getting heat, the ice cream will gain heat from the hot water, and which means that we want it to melt the slowest, therefore the container must be made of a poor conductor of heat. So which stick of ice cream will take the longest time to melt? Definitely it is the container here. And this ice cream will be ice cream stick P. Right? This is a question, it is a 2-in-1 question, so let's make sure you answer both questions. Part 1 is simple, right? Part 1 is simply ice cream in the plastic container melts the slowest. And why? This is where the part 2 comes in. Plastic is the poorest conductor of heat. So it slows down the heat transfer from the hot water to the ice cream the most. Words such as poorest, the most, are words used to make comparison. And since this is a question that you need to compare, you got to use words that show us you have made a comparison before coming to your conclusion. Now let's go on to the second question. The diagram below shows a cross-section of a solar panel used to heat water for the household. The owner of the house wants to buy the most suitable material for constructing the solar panel. Now this is a case of a novel situation. Novel means it is new to you. Some of you may not even know what is a solar panel. If you know what's a solar panel, you may not know how it works, or you think like it is not like this. Okay, so this is a novel situation, but don't worry when you come across things you have not come across before. Just need to look at what is the concept being tested. I see, okay, whatever this thing is, it has to heat up water. So usually people want the water to heat up quickly. Nobody wants to boil something forever, isn't it? Take forever to boil. You want something that can boil water quickly, heat up water quickly. So therefore, when we say most suitable, we are actually asking you what is the property that is considered to be most suitable. Therefore, it must be looking for a material that is a good conductor of heat. The question did not ask you which is a good conductor of heat. You got to come to this question yourself. Alright, that this is actually what the tester wants you to tell us by inferring from the question. The diagram here is a rooftop. So cold water will be pumped into the pipes. As it pumps to the pipes, somehow the water in the pipes are gaining heat, and then hot water will come out. That's the idea of this solar panel. Now let's look at the graph. The graph below shows the rate at which the amount of water is heated up in 4 identical beakers made of different materials. There are some words here that needs to be unpacked, like the word rate. What does rate means? Now rate is usually not faster or slower. When you use faster or slower, you're talking about speed. So be very careful not to use faster or slower. Rate actually means, in this case here, how much the temperature increases in the same amount of time. Right? It's the amount of increase in the same amount of time, or amount of decrease or change in the same amount of time. That is the idea of rate. And when we see identical beakers, usually it means really identical. But in this special case here, identical actually means similar. Alright, so it means that in this case here, the shape is the same, the size is the same, but the materials are different. So in my opinion here, it's actually better to use the word similar because they may have different materials. Now let's take a look at the graph. Right, temperature here, time here. Now I find it easier to understand when I can see numbers. So I'm going to put in some fictitious number. It doesn't matter if the numbers are not in the question, so long as the numbers make sense to you. Let's start with 5 minutes, for example. Let's say at 5 minutes. If I understand rate as in the same amount of time, so I like to see after 5 minutes what has happened. So I mark 5 minutes and I draw a line, vertical line out that cuts across all these graphs. Then I'll draw a horizontal line across to cut the temperature graph like this. Okay, I will cut 4 of these graphs at these points and I draw across. Now I need some numbers here to help me make sense of all where these things are. So I put in some numbers. Let's assume at first it was at 20 degrees Celsius. And so after 5 minutes, the water in material D actually increases to 30 degrees Celsius. After 5 minutes, the water in container C increases to 40 degrees Celsius from 20. Alright, after 5 minutes, the water in container B increases by 30 degrees Celsius from 20 to 50. After 5 minutes, the water in container A increases from 20 to 80. Wow, that's the most increase ever. Right, increase the most by 60 degrees Celsius. Remember, we're talking about which material is the most suitable. You will look for a good conductor of heat. So different materials here, definitely some will be good conductors of heat. And the temperature of water in beaker A increased most, as we have seen from the graph, in the same amount of time here. That means that material A must have allowed heat to pass through it most easily, which means that A is the best conductor of heat, and that is what we want. But just to complete the understanding, some will be poor conductors of heat. Now, don't carry on first. Tell me which is the poorest conductor of heat. Material A, B, C, or D? You're right. It is D. D is the poorest conductor of heat. Now, with the understanding, we can proceed on to answer the question. Which of the material is the most suitable to make this pipe, and which is the least suitable? Of course, the most suitable must be the best conductor of heat. So that will be A. The least suitable must be the poorest conductor of heat, and that will be D. Now come the slightly tougher part. Why do you choose the material in part A? Now, if you've understood the question the way I've explained to you, alright, then answering it is easy peasy. So why? Let's talk about the science concept. Always talk about the science concept. Okay, and the science concept here is good conductors of heat allow heat to pass through them more easily than poor conductors of heat. What does this mean? It means that whatever is in a good conductor of heat, like water in this case, will gain heat faster than poorer conductors of heat in the same amount of time. Now I can answer this. A is the best conductor of heat. Well, this shows my understanding. And when I use words like best, I'm making comparison with B, C, and D. But that's not enough. It is the best conductor of heat. So what? So the increase of water, the temperature of the water is the most in the same amount of time. This one makes reference back to the idea of rate. Now let's go on to question 3. Aramitha carried out an experiment to find out which type of cup made of different materials was better for keeping tea hot. Alright, so in this question actually, it's quite straightforward. If all you need to know is to find out, and there's an aim, and you know that conclusion here means the answer to the aim, then all you need to do is look at the graph. Okay, after 20 minutes, the temperature of the hot tea in cup X is at 61 degrees Celsius. Temperature of the hot tea in cup Y is at 77 degrees Celsius. So, of course, cup Y is better for keeping tea hot. And that's all I need to write. Now this. However, if I just look at the graph in this very simplistic way, I will find it difficult to answer part B. So let's unpack the graph here with more understanding, so we can answer part B. Alright, again, always go back to what is the concept being tested. We talk about hot, talk about different materials. This must be under the topic of heat. It must also be under the concept of heat conductivity of materials. So we must find out to keep tea hot. Therefore, we must be looking for the poorest conductor of heat, because that will not let heat pass through easily, which means that the hot tea will stay hot for a longer time, because the hot tea will lose heat to the surrounding much more slowly compared to the hot tea in a better conductor of heat in the same amount of time. The cups were left on the table at room temperature, and the temperature of the tea in both cups were taken at 5 minutes interval. The results are shown in the graph below. Let's unpack this. Now, what is the starting temperature of the hot tea in both cups? And both cups were the same size, and equal amount of hot tea. All these variables are kept the same. Amount of hot tea, size of the cups, as well as the starting temperature. This is actually at around 90 degrees Celsius. Room temperature, I will assume, is around 30 degrees Celsius. This may change, so I use the word around just for my understanding. Now, so this is the starting temperature of the hot tea. Now, I'm going to draw a horizontal line across this so I can make comparison. Because when we talk about increase or decrease, we got to know where it starts from and where it ends. So, and the original temperature of the hot tea was here. Let's look at cup Y first. Alright, temperature dropped by this amount after 20 minutes. That means it's dropped by 13 degrees Celsius to 77 degrees Celsius. How about the hot tea in cup X? Well, that dropped a lot more, from 91 degrees Celsius to 61 degrees Celsius. So it dropped by 29 degrees Celsius. This tells us that more heat is lost by the hot tea in cup X to the surroundings compared to cup Y. So this means, of course, that cup Y is a poorer conductor of heat. Okay, now let's go on to part B. In another experiment, Aramitha poured an equal amount of cold water into cup X and cup Y. Now it is the same cups, but different kind of liquids. Now instead of hot tea, it used cold water. Which cup is likely to have a lower temperature after 10 minutes? Explain your answer. 2 parts. So I'm going to draw a diagram. I find diagrams and numbers make things easier for me to understand. So I have a diagram of cup Y and cup X, and the surrounding temperature is around 30 degrees Celsius, same for both. So this means that heat is flowing from the surroundings into the cup, into the hot water, into the cold water. So the cold water in both cups are gaining heat. The containers are gaining heat from the surroundings. So heat's flowing this way, 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 and this way. But which container will gain heat the slowest? Which container will gain heat the fastest? Let's make a comparison. Now, we know that cup Y is a poorer conductor of heat compared to cup X. And the material used to make cup Y is a poorer conductor of heat. That means that heat cannot pass through it easily. That's the idea, that's the meaning of poor conductors. Heat cannot pass through it easily. So, it means that the cold water inside this container will gain less heat in the same amount of time. or some of you use a more simplistic language, you'll gain heat slowly. And finally, the temperature of cup Y itself will increase less because it is slowing down the rate of heat transfer. So therefore, if the temperature of cup Y is less, increases less, it will have a lower temperature compared to this one. Let's understand what's happening here. Cup X is a better conductor of heat compared to the material used to make cup X is a better conductor of heat compared to the material used to make cup Y. That means that heat can pass through it easily, more easily compared to this. And therefore, the cold water in this container will gain more heat in the same amount of time compared to the cold water here. That also means that the temperature of this cup will increase more compared to the temperature here. Therefore, the temperature of cup X is higher. Which cup is likely to have a lower temperature after 10 minutes? Clearly, the answer is cup Y will have a lower temperature after 10 minutes. As you can see here, this understanding that I built up for you. Now let's explain. Explanation, well, if you have understood all this, explanation is going to be easy peasy. So, because the material used to make cup Y is a poorer conductor of heat than the material used to make cup X, so cup Y gains less heat in the same amount of time and its temperature will be lower. All these explanations were here. Now, just a reminder, whenever you make comparisons, you must use words such as like lower, poorer, better, so on and so forth. Okay? Now let's go on to the last question. This question, I will not explain too much. I will explain it in class with you. Alright, you can also watch my other video. I have one video with a test tube with colored water. I've explained it quite clearly there. What happens to the rise and the fall of the colored water. Now, I also show you here an example of an answer given by one of my students. And this answer is good, but it is incomplete. And the complete answer is here. And I'm sure you have learned CER from your science teachers before. I don't really teach you CER, but I will teach you something that's a bit different. Okay, but the idea is similar. So the claim here is, because which basin was filled with the highest temperature of water, the claim you make, basin R is filled with the hottest water, or the water at the highest temperature. The evidence, the drop in the ink in tube R is the drop of ink in tube R rise the highest. Alright, this drop of ink in tube R rise at the highest. And why? That's because the air in the tube R gained the most heat from this hot water, and therefore it expanded the most and pushed up this drop of ink to the very highest. Alright, I hope you've enjoyed this video. I'll see you in the next one. Goodbye.